Here we have a SAT math question. Okay, let's go to the information. The sum of the roots of a cubic polynomial g of x equals to ax cubed positive bx squared positive cx positive d is 6. If g of x can be expressed as x squared into 4x positive 4 times x positive k, what is the value of a positive, b positive, c positive, d? Okay, the question says that g of x, the cubic polynomial is given over here. G of x equal to ax cubed positive bx squared positive cx positive d. And the same g of x can be written in factor form, that is x squared into 4x positive 4 times x positive k. So already we know that this is a cubic polynomial equivalent to g of x. Let me write that cubic polynomial, that is ax cubed positive bx squared positive cx positive d. And also g of x can be written in this factor form. Since g of x can be written in this factor form can be equated to the cubic polynomial given over here. Then we get x squared negative 4x positive 4 times x positive k. So here the expression we have on the left side, the expression we have on the right side, both of them are equal to g of x. So that I equated these two expressions. Okay, now my aim is to find the value of this constant k. So once I get the value of this constant k, I can multiply these two expressions and I can compare the coefficients of x cube, x square, x and constant term and get the values of a, b, c and d. Then I'll be able to get the value of the expression a positive, b positive, c positive, d. So now my aim is to get the value of this constant k. So how do you have to get the value of the constant k? So for that, we can consider the information we have in the question. That is the sum of the roots of a cubic polynomial g of x is 6. That is, if I equate g of x to 0, I'll be getting 3 roots for this equation because g of x is a cubic polynomial. So and also the sum of the 3 roots is given, that is 6. So when I solve this equation g of x equals to 0, I'll be getting 3 roots. So the sum of those 3 roots is 6. And also the question says g of x can be expressed in this form. So now we can replace this g of x by this product of the two expressions. That is x square negative 4x positive 4 times x positive k equals to 0. Okay, now the product of the two expressions equals to 0. Either the first expression equals to 0 or the second expression equals to 0. Then we get x square negative 4x positive 4 equals to 0 or x positive k equals to 0. If I solve for x in this one, for that I have to get out this positive k. Let me subtract k from both sides to isolate x on the left side. Then I'm getting x equals to negative k. Okay, as I said already, we have 3 roots for this equation. So I just got one root of the equation over here, that is negative k. So if I solve this quadratic equation, I'll be getting 2 more roots. But I don't have to solve this quadratic equation. Better I can get the sum of the 2 roots of this quadratic equation. So that will be easier. So to get the sum of the 2 roots of this quadratic equation, let me consider a quadratic equation standard form, that is ax squared positive bx positive c equals to 0. So without solving the quadratic equation, if I want to get the sum of the 2 solutions, there is a formula, that is negative b over a. I have to take negative sign, then I have to take the coefficient of x. It has to be divided by the coefficient of x squared to get the sum of the roots of the quadratic equation in standard form. Okay, now our quadratic equation over here, one second, is in standard form. So to get the sum of the roots, let me write the stuff over here. Sum of the 2 roots. Let me write it. Sum of the 2 roots equals to negative b over a. So here negative. So the value of b is the coefficient of x. In this case, it's negative 4 over the value of a is the coefficient of x squared, that is 1. So when I simplify this one, I'm just getting 4 because negative times negative is positive. 4 over 1 is just 4. Okay, for this quadratic equation, I got the sum of the 2 roots 4. And in this equation, I got 1 root, that is negative k. Now, to get the sum of the 3 roots of this equation, I just have to add the sum of the 2 roots over here and 1 root over here. So when I add them, I'm getting 4 negative k. So this expression represents a sum of the 3 roots of this equation, but it's already given in the question, that is 6. So 4 negative k equals to 6. Now let's solve for k in this equation. For that, I have to subtract 4 from both sides. When I do so, positive 4, negative 4 will cancel. I'm getting negative k equals to 2. So now to get the negative sign, I have to multiply both sides of the equation by negative 1. So when I multiply this negative k by negative 1, it will become just k. When I multiply this 2 by negative 1, it becomes negative 2. Okay, now I got the value of k, which is negative 2. Okay, now let me plug in k equals to negative 2 over here. Let me continue the problem from this step. So let me write the expression on the left side as it is. It is ax cubed positive bx square positive cx positive d equals to x square negative 4x positive 4 times x. So for this k, I can plug in negative 2. So already we have positive sign over here. If I plug in negative 2, positive times negative will become negative. So it becomes x negative 2. then I'm getting ax cube positive bx square positive cx positive d equals to, so now I have to multiply these two expressions. Okay, let me take this x square first. It has to be distributed to both x and negative 2. So when you do such a distribution, x square times x is x cube. When you distribute this x square to negative 2, it will become negative 2x square. Now I have to distribute this negative 4x to this x, negative 4x to this negative 2. Then I'm getting negative 4x square positive 8x. Now let's distribute this positive 4 to the to this x and negative 2. I'm getting positive 4x and negative 8. Let me continue the next step. Ax cube positive bx square positive cx positive d. I have written the expression on the left side as it is. Now let me combine the like terms on the right side. So negative 2x square, negative 4x square are like terms because both the terms contain x square. When I combine them, I'm getting negative 6x square. Here I can combine positive 8x and positive 4x. I'm getting positive 12x, negative 8. Okay, now the expression on the right side is completely simplified. Now we can compare the coefficients of the like terms so that we'll be able to get the values of a, b, c, and d. So now if I compare the coefficient of x cube, so here I'm getting a, the coefficient of x cube on the left side. The coefficient of x cube on the right side is just 1. So a equals to 1. So whenever two expressions are equal, the coefficients of like terms must be equal. So the coefficient of x cube on the left side, the coefficient of x cube on the right side must be equal. Now let's compare the coefficients of x square. On the left side is just b, on the right side it is negative 6. So b must be equal to negative 6. The coefficient of x on the left side is c, on the right side is positive 12. And the constant term on the left side is d, on the right side is negative 8. Now I have the values of a, b, c, and d. So now mine is to find the value of this expression a positive, b positive, c positive, d. Okay, let me write that expression over here. That is a positive, b positive, c positive, d. Okay, now in this expression we can plug in the values for these four constants. We know that the value of a is 1, so we can plug in 1 for a. And for b we have negative 6, so we can plug in negative 6 for b. And for c we have 12, we can plug in 12 for c. And for d we have negative 8, so we can plug in negative 8 for d. Okay, now let's combine the two positive values 1 and 12, which becomes positive 13. When I combine the two negative values negative 6 and negative 8, it becomes negative 14. So when I combine 13 negative 14, it will become negative 1. So therefore the value of the expression a positive, b positive, c positive, d is negative 1.